A very good morning to you students. Today I am going to discuss you the relation between roots and coefficients of a polynomial equation, which is an important part of the syllabus in unit 2. So how to find the relation between roots and the coefficients? You know what is the roots and what is the coefficients of a polynomial. So how to find the relation between them? Okay. So you are given this polynomial fx of degree n, that is of this form: x to the power n plus p1 x power n minus 1 plus p2 x to the power n minus 2 plus dash dash plus p suffix n minus 1 x plus p suffix n is equal to 0. So this is a polynomial of degree n. Name it as equation 1, and let us suppose alpha 1. Since it is of degree n, so there will be at most n roots. So let us name those roots in general as alpha 1, alpha 2, dash dash alpha n be the roots of this given polynomial equation 1. Now, if these are the roots of the given polynomial, then by factor theorem, fx can be expressed as a factor of these roots, that is x minus alpha 1 into x minus alpha 2 dash dash into x minus alpha n. So we name it as equation 2. Now multiply this. When you multiply each term, first you multiply the first and the second and the third dash dash and the last with the last. What you will get is this x to the power n minus you will get this expression. Once you multiply this equation to the right hand side of 2, you will get this expression, that is x to the power n minus alpha 1 plus alpha 2 plus dash alpha n into x power n minus 1 plus dash dash plus alpha 1 alpha 2, that is sum of the roots taken 2 at a time, that is the coefficient of x power n minus 2 minus the sign. See, alternate signs with their plus minus and so on, dash dash the last term. Because this is of degree n, it will be minus 1 to the power n into the product of all the roots, that is alpha 1. For example, if you are given this polynomial fx of degree 3, that is x to the power 3 plus p1 x squared plus p2x plus p3. Let alpha, since it is of degree 3, so there will be at most 3 roots. So name them as alpha 1, alpha 2, alpha 3 be the roots of this given equation 1. So by factor theorem, express this fx as a factor of these roots, that is x minus alpha 1 into x minus alpha 2 into x minus alpha 3. So first of all, what you need to do is multiply these two parts, that is x minus alpha 1 into x minus alpha 2. What you get is x into x is x squared, x into minus alpha 2, you will get minus x alpha 2, minus alpha 1 into x, you get minus alpha 1 into x, minus into minus plus, that is alpha 1 and alpha 2 into this third polynomial, that is x minus alpha 3. Now multiply each of this with this with this with this, and this with this. What you get is x cubed minus x into x gives you x squared, but because of alpha 2 here, x into x cubed and then x squared into alpha 3, you have this. Now minus x alpha 2 into x gives you x squared into alpha 2 minus x alpha 2 into alpha 3, you will get x alpha 2 alpha 3. Now this multiply with this, you will get x squared into alpha 1 minus into minus plus, you will get x alpha 1 alpha 3, and then multiply this alpha 1 alpha 2 into x, you get plus alpha 1 alpha 2 into x minus, because this into this gives you alpha 1 alpha 2 into alpha 3. So you have minus sign here. Now from this, you take the coefficient of x square separately, add them. What are the coefficients of x square here? That is minus alpha 3 minus alpha 2 minus alpha 1. So you have x cubed will remain as it is, x cubed minus alpha 1, take the minus sign because it is common to all the three terms, x square outside. So you have inside the bracket will be alpha 1, alpha 2, alpha 3, and then plus. Take the coefficient of x. There are three terms and all are plus. So you can write plus here. So alpha 1, start with this, alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 3 alpha 1 into x. These are the coefficient of x, and then minus alpha 1 alpha 2 alpha 3, but this minus you can replace it by minus 1 to the power 3, because this fx here is a polynomial of degree 3. So you write minus 1 to the power 3 into alpha 1 alpha 2 alpha 3. Now as you can see here, equation star and double star, they are identical. See, this and this, they are identical. So comparing the coefficients and the roots of this polynomial, so you have here minus alpha 1 alpha 2 alpha 3, that is coefficient of x squared. Here it is p1, whereas here it is this. So you have minus alpha 1 So by comparing here this coefficient of x square in its star, it is p1, and here you have this one, so you have minus alpha 1 plus alpha 2 plus alpha 3 is equal to p1, or you multiply both sides by minus sign, you get alpha 1 plus alpha 2 plus alpha 3 is equal to minus p1. So this is sum of the roots. Now you take the coefficient of x here, it is p2, whereas in this star it is the sum of the roots taken 2 at a time. So you have here alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 3 alpha 1 is equal to p2. Now what is p3 here? The constant term of equation star, it is p3. And what is the constant term of double star here? It is minus 1 to the power 3 into alpha 1 alpha 2 alpha 3. So this gives you, this must be equal to p3. Multiply both sides by minus 1 to the power 3 here. So what you have here is alpha 1 alpha 2 alpha 3 is equal to minus 1 to the power 3 into p3. That is the product of all their roots. So in general also, for this polynomial of degree n, by comparing this with this, what you get is p1 will be equal to this, p2 will be equal to this, p3 will be the coefficients of x to the power n minus 3 dash dash. The constant term pn here will be this. Now this minus sign, you replace it, but so it will become here in general alpha 1 plus, that is sum of the roots taken, and sum of all the roots is equal to minus p1. Sum of the roots taken 2 at a time will be equal to p2. Sum of the roots taken 3 at a time will be equal to minus p3 dash dash, and product of all the roots will be equal to minus 1 to the power n, since it is a polynomial of degree n. So this n here stands for the degree of the polynomial. If it is of degree 4, you will get minus 1 to the power 4. If it is 5, it will be minus 1 to the power 5 into p5 and so on. So in general it will be minus, that is the product of all the roots will be minus 1 to the power n into pn. Now with the help of this relation, you have to remember is, all this is a kind of formula you have to remember to find this is the relation between, these are the roots and their coefficients. So this is with the help of this, I'm going to show you one example how to solve this polynomial x cubed minus 5x squared minus 4x plus 20 equals 0, given that 2 of its roots, since it is of degree 3, there will be at most 3 roots, but 2 of its roots, they are equal but opposite in sign. So you have here x cubed minus 5x squared minus 4x plus 20 equals 0 is a given polynomial equation, which can be rewritten as x cubed plus minus 5 into x squared plus minus 4 into x plus 20 equals 0, which is of the form x cubed plus p1x squared plus p2x plus p3 equal to 0. So from here you compare it. What is p1? P1 is minus 5, p2 is equal to minus 4, and p3 is equal to 20. So you have p1 is equal to minus 5, p2 is equal to minus 4, p3 is equal to 20. And according to the question, 2 of its roots are equal and opposite. And since it is of degree 3, there will be 3 roots. So let us name those 3 roots as alpha, because 2 of its roots are equal but opposite. So if alpha is one of the root, then the other root will be minus alpha, which is opposite to this. And the third root, let us name it as beta, be the roots of this polynomial equation. Now, sum of the roots, using this relation between roots and coefficient, what are the sum of this root? Alpha plus minus alpha plus beta is equal to minus p1. And what is p1 here? P1 is minus 5. So this implies alpha and minus alpha can be cancelled. Implies beta here is equal to minus of minus 5, because p1 is minus 5, which implies that beta is equal to 5. Now you got the value of one of the root, that is beta is equal to 5. Now sum of the roots taken 2 at a time. Sum of the roots taken 2 at a time, that is alpha into minus alpha plus minus alpha into beta, alpha into this into this, and then plus beta into alpha will be equal to p2. What is p2 here? P2 is minus 4, so I'll replace it by minus 4. Now alpha minus alpha, so you'll get minus alpha square, and then minus alpha into beta plus alpha into beta is equal to minus 4. So this and this can be cancelled, implies that minus alpha square is equal to minus 4. Minus minus can be cancelled, implies that alpha square is equal to 4. So which implies that by taking the square roots, you will get alpha here will be equal to plus or minus 2. So therefore, these are the roots. What are the roots here in the given equation? We name it as alpha minus alpha and beta, and what we have got, the value of beta is equal to 5, and alpha, if you take alpha is equal to plus 2, the other roots, but that is the negative of this first root, will be minus 2. Now if you take alpha to be minus 2, then the second root, that is minus into minus 2, will give you plus 2. So hence the roots of this polynomial equation are minus 2, 2 and 5. I hope it is clear to you. So the rest of the problems, some more problems I'll explain through screencast. So the rest of the problems you try to understand it. If anything is not clear, then you just let me know.